Imagine a world where telling the difference between a person and a machine, well, it takes more than just a quick look.
Yeah.
We're talking faces that actually show emotion, movements that seem full of life, even sounds like, laughter that feels real.
It sounds like science fiction, doesn't it?
It really does. But according to this incredible stack of sources you shared with us,
Hmm.
this is just, well, maybe not every Tuesday, but it's happening right now in hyper-realistic robotics.
It's genuinely astonishing. And the sources, they don't just cover the tech side, do they? They paint this really full picture of how these machines are pushing the boundaries of how we perceive things.
Right. So our mission for this deep dive today is to kind of pull together all this global progress, get the facts on how close science really is to creating a digital human.
And crucially, what that means psychologically.
Yeah.
What happens when that line gets blurry.
Okay, so let's dive right in at that threshold, the uncanny valley. That kind of weird, unsettling feeling you get when something looks almost human, but not quite.
Exactly. Where the resemblance itself causes unease.
And the first project here that just leaps out is this A-wide study. It's, 1.7 meters tall, described as elegant.
And it's designed very specifically as a psychological test, really. A litmus test for the public.
So it's not about what it does necessarily. Not yet, anyway.
Not primarily. It's an experiment in perception. Scientists are using it to research the effect of machines that simulate humans to, well, an extreme degree.
And the key feature is the movement.
Yeah, astonishingly natural movement, particularly the face and arms. It can speak, laugh softly, and show a range of emotions. It's limited, sure, but apparently very effective.
And the public reaction really tells the story there, doesn't it? The sources say people were just completely divided.
Totally. Some people rushed up, wanting photos, just completely awestruck.
But then others actively avoided it, felt uncomfortable.
Or just stood there watching kind of an silent, anxious astonishment. That split reaction, that's it right there.
That's the moment it crosses over from being just a clever gadget to something unsettling, an imitation.
That anxiety is exactly what these projects bring to the surface. It tests our acceptance or maybe our resistance to something that mimics us so closely. If it looks perfectly human, do we trust it more? Or are we, inherently suspicious?
That's a huge question. Okay, so speaking of things that are highly visible, let's talk about Jiang Lili from China, right? X-robots.
Absolutely. She's less of a lab study and more like a media phenomenon.
Introduced on national TV as a presenter.
Yeah, exactly. And she's designed to look like an 18-year-old virtual girl, loves singing, comics. It creates this comfortable, sort of relatable image.
But there's more under the hood, so to speak.
Oh, definitely. That charm hides some serious capability. The sources mention supernatural abilities in data analysis and intelligent interaction.
Right. I can see the debate starting immediately. She becomes this perfect symbol. Some people see a technological marvel.
While others are immediately thinking, could she replace human presenters, media personalities?
Yeah. It brings us right back to that core question you raised. When does that resemblance tip over from astonishing to frightening? Is it when it can do your job better, or just when it can look like you while doing it?
Or maybe it's the combination. When the tech makes the human role unnecessary and it looks just like us, that's potent.
That is potent. Okay, so we have established they can trick the eye, sometimes unsettlingly well. But a good illusion needs brilliant mechanics underneath, right?
Exactly. Now we need to look past the skin, past the appearance, and talk about what's actually, moving these things.
This is where the engineering starts to sound like biology.
It really does. And we head over to Poland for this, to the Clone Company and their Forso project, which sounds incredibly ambitious.
It does. Redefining the robot not with stiff mechanics, but through biomechanics.
Exactly. A deep study of how we move. They're focusing entirely on the upper body.
So it literally has a spine, a neck, shoulders, arms, flexible fingers.
The whole upper assembly. And get this, the sources say the 4 main joints were completely redesigned to work exactly like human joints.
Okay, hold on. How do you replicate organic muscle function with hardware? That seems like the biggest hurdle.
Well, they use something called hydraulic artificial muscles. It's based on the McKibben motor principle.
Okay.
Think of it like this internal tube that expands, but it contracts lengthwise when it does.
Yeah.
Just like how real muscle fibers contract.
Wow. So that gives it that smooth, realistic movement.
Incredibly smooth, yeah. It allows it to do really detailed stuff like holding tools precisely, or maybe even assisting in physical therapy down the line.
The precision must be incredible. The source mentioned a hand capable of lifting just 18 grams.
18 grams, yeah.
Yeah.
That's That's staggering sensitivity.
Mind-blowing. Okay, so if the torso project is nailing fine manipulation, then Hobby 02, this one's from South Korea, Cake Ayest, this is tackling movement on a bigger scale. Locomotion, efficiency.
Right. UBO2 is all about being fast, light, and efficient. Weighs only 45 kilos, apparently twice as fast as the previous version.
And how does it achieve that efficiency? Is it the walking style?
Yeah, it's got this optimized knee bend and a very straight, smooth gait. That cuts down energy use dramatically compared to older, maybe clunkier robots. That's much more natural walking.
And the hands, too. Still incredibly dexterous.
Oh, yeah. Hands weighing just 380 grams each, but packed with 5 tiny motors, torque sensors.
Allowing it to do complex things like grasping and, the sources mention, fencing. Seriously.
Yes, fencing. It sounds almost comical, but it demonstrates incredible speed, balance, and fine motor control.
We're basically a software update away from a robot winning an Olympic medal, then.
Well, maybe not quite yet, but it shows we are definitely past the era of clumsy, slow-moving robots. These machines move with confidence, biological grace almost.
It's amazing how fast the focus seems to shift, though, from pure engineering challenges to, okay, how do we actually use these things?
Right. Once you have a machine that looks convincingly human, moves fluidly, the next logical question is, where do they fit in our daily lives?
Exactly. So let's look at where these incredibly complex creations are starting to show up, moving them out of the lab and into, say, the classroom or the home.
Education is definitely emerging as a huge area. Look at the Da Vinci robot from Japan, revealed at the G20, no less.
Designed as a live teaching tool, embodying the spirit of Da Vinci himself.
Yeah, teaching in multiple languages.
Yeah.
Trying to make learning more engaging, more present.
It turns the classroom into something more dynamic, I suppose. But what really struck me was the ambition. Right now, it just repeats program stuff, right?
Heck wreck.
But the future goal is huge, linking it to AI systems like Google to become a real-time conversational teacher.
It's a massive leap.
Yeah.
And they're already planning an Einstein version too, apparently.
Wow.
And it's not just high-end concepts. You also see products aiming for accessibility, like Miko 3. That's a global educational companion. Starts around $250.
Okay, much more accessible.
Yeah. Designed to be fun, soft plastic, but backed by a really extensive library of educational apps developed with teachers, psychologists. It's meant to foster curiosity.
More like an interactive friend than just a, standard voice assistant.
Precisely. Responsive, engaging.
Okay, so from the classroom, let's move into companionship. This is where things get kind of wild, I think, where the engineers seem to start focusing just on tasks and start aiming for emotional presence. Warmth.
Yes, exactly.
Yeah.
Let's talk about Eva and Yuki. Their design philosophy is really fascinating.
Eva first. Around $5,500. The unique thing is the material.
Right, a specialized material, DPI they call it, designed specifically to mimic human skin texture and get this warmth.
Warmth. Okay, so it's designed for affection, fun, emphasizing that human-like touch and feel.
Mm-hmm.
But here's the thing that feels almost manipulative. If the goal is genuine connection, isn't programming warmth just creating a very expensive dependency?
That's the ethical tightrope, isn't it?
And look at the response design. The sources say Eva intentionally pauses for 1 or 2 seconds before responding.
Yeah, to simulate thinking. Sincerity, like it's actually considering what you said.
That tiny engineered flaw makes it feel more authentic.
It's kind of brilliant, in a way. They're engineering the slight awkwardness, the hesitation that makes interactions feel, well, human.
Okay. And Yuki. Pricier, around $7,000. What's her focus?
Yuki's about generating simple happiness, quicker responses, apparently has a sense of humor, plays music, games.
And the mission is just proving robots can create little sparks of joy, unplanned moments.
That seems to be the idea. A warm presence, a light laugh in her voice. It's about positive emotional feedback.
And then you have Alec. Much cheaper, $250. This one seems to distill emotion down to its basics.
Totally. Small circular body, digital face. It responds directly to touch.
How so?
Like a gentle stroke on the head makes virtual stars appear on its face. But a sudden press, it does a virtual scream, shows tears. Very direct emotional feedback.
Wow. Like a digital pet, almost, but more interactive.
Sort of. It can hold conversations, apparently. And fascinatingly, the sources say 2 Alecs can interact with each other, argue, even fight like siblings.
Fight like siblings. That's hilarious.
Yeah, in a humorous way, they say. It just shows that engineers aren't just thinking about tasks anymore. They're thinking about providing warm domestic presence, social interaction.
This whole shift it's really something. We've gone from engineering the mechanics of a spine to engineering subtle empathy.
Yeah.
Programming in flaws, warmth, even that thinking time hesitation, all to make the interaction feel fundamentally authentic, less like giving a command, more like connecting.
They definitely want us to connect, not just command. That seems clear.
Absolutely, and when you kind of pull back and look at the whole range we've covered today.
Right, from AY testing our psychological boundaries, that deep unease.
To the sheer physical capability of UBO2 moving with that biological grace.
And then landing on the emotional niche being filled by companions like Eva and Yuki. The overall picture is pretty clear, isn't it?
Yeah, every source we looked at seems to point in the same direction. That line, the one between human and mechanical, it's narrowing incredibly fast.
Faster than we probably realize.
Making that future of, integrated living feel much closer than maybe we thought. We're building these companions, educators, collaborators that are becoming almost indistinguishable from us in some ways.
Which I think leads us to a really interesting final thought for you, the listener, to chew on after this deep dive.
Okay.
We've seen robots designed for all sorts of things. Service, teaching, even just being there for company. Now, if these hyper-realistic machines can offer affection, maybe a sense of humor, even a warm skin-like touch, is the real value of a robot going forward measured by its ability to serve us? Or is its value actually measured by its ability to make us feel, well, less alone?